features available in Teradata. So there are a couple of things like journals. In journals, we'll be seeing about transient journal, permanent journal. So permanent journal will be split into like before and after. And then we'll be seeing about the down arm recovery journal. And we'll see what will happen when there is a disk failure and there is a node failure.
Okay.
So journals are nothing but it used to capture the information about our table in Teradata. It's like a snapshot of your table. So the first journal we will be seeing about transient journal. So Teradata uses this transient journal to protect the data from transaction failures. So as you know, Teradata is auto commit one. So whenever there is a transaction going on, like when you do a insert update or something, right? So there will be, that is called a transaction. So whenever any transactions are run, transient journal keeps a copy of the before image of the affected rows. Okay, so this journal will be having your before image, and whenever the transaction fails in between. Okay, so even if you aborted in between the transactions, so what will happen? The transient journal will apply the rows back as a rollover, means as a failover. Okay. So whenever any transactions are run, transaction journal keeps a copy of before image of the affected rows until the transaction is successfully rolled back successfully. So once the transaction is completed, the before image, the snapshot will be discarded. So transient journal is kept in each AMS. So it is an automatic process and cannot be disabled. So whatever rows which are getting changed, right? So that will be kept in each AMP where the data resides. Okay.
Okay.
So that is about the transient journal. And one more thing about this transient journal is whenever you have a heavy insert or update or delete going on, and when you abort it in between or it failed, right? So it started, it will be using the DBC space actually. Got that right? Like if you're doing delete on say insert on 1 TB of more than 1 TB of table size. In that case, the transient journal will be moved. So we need to monitor these aborting sessions, and we need to check whether the DBC space is occupied. So when it is getting completed quickly, we don't have any issues. We don't see any problems. But it is getting used, right? When the transient journal is rolling back, it will take some time. In that case, it will affect the database. So,
okay.
And the next one is about the fallback. So this fallback feature is for app failure protection. So fallback protection helps in case of failure, like when an app goes down, like the Unix process like vproc or AMP, right? So when that goes down, then this fallback will come into the picture. So fallback protects the table data by storing a second copy of the rows of the table into another app called as the fallback app. Okay. So it stores the data always in another app, not in the same app. So in case app and goes down, then the other app data can be there. So fallback option can be used at the table creation or after the table creation also. So you can alter the table also and make it as fallback. Fallback ensures that the second copy of the rows of the table is always stored in the another RAM to protect the data failure. However, fallback occupies twice the storage and IO for insert, delete, and update. So the thing is, when you make a table as a fallback, right? So when you read, only single copy will be read from any of the app. But when you write, so it has to do a duplication the other app too. So in that case, you have to sacrifice twice the space, the IO, right? And even the time will be increased. So this is example of how to create this fallback. So create set table or multi-set table name, and then you mention it as fallback. Okay. So this is automatically taken care by the system. We just need to mention it to be fallback. So in case if it normal table, right, we'll be writing no fallback. So here we write it as fallback. So this is an example of fallback. Okay, so you can see here when the fallback is enabled, you see the row 1, which is the primary row. So it is stored in AMP1. And if you see in the fallback AMP, like row 1 is stored in AMP2. Similarly, row 5, which is in AMP1, will be stored into AMP2. So in case of AMP1 failure, so we can still retrieve the data from row 1. I mean, we can retrieve the row 1 and row 5 from AMP2.
Okay.
So yeah, so this is what I was saying. During the normal processing, reads are performed using the primary copy, while updates are performed on both the updates will be performed on both the copies. So the database maintains a log of changes, by inaccessible copies, and automatically updates the missed changes to synchronize the table copy when it becomes accessible. This means like whatever changes done. Okay, suppose you are updating here, like when the AMP1 goes down, you do some operation with the row 2 or row 6. Okay, so in that case, right? Row 1 or row 5 in that case, right? So that this will be written into a log. So once the AMP comes back, so this whatever changes done here, it will be automatically synced here with the AMP which was down during the operation.
Okay.
So this fallback will be achieved by this down AMP recovery journal. So a down AMP recovery journal is activated when AMP fails and the table is fallback protected. The journal keep track of all the changes to the data of the failed AMP. Okay, and the journal is activated on the remaining AMPs in the cluster. So means like when this AMP down AMP recovery journal is activated, right? So once one AMP goes down, it will be automatically activated for all the remaining AMPs to avoid the failures. So once the fail AMP is live, then the data from the down AMP recovery journal is synchronized with the AMP. Once this is done, this journal will be discarded. So we saw about 2 journals, right? One is transient journal, the second one is down AMP recovery. So transient is for transaction failures protection, and this down AMP is for AMP failure. Okay.
Okay.
So the next thing, yeah.
Something down AMP journal works whenever there is an AMP failure also, right?
Yeah, down AMP will work whenever there is AMP failure only.
Okay. If AMP is down means that is also go with the same scenario.
Yes, that is a scenario, like when AMP is down.
Okay, okay.
If
No,
you see
failure
here,
is different. No, failure is different, and going down is also that is different scenario. No, that is performance level.
failure, no, failure in the sense you are telling like app is not able to retrieve the data, something like that.
Okay, 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 fine. Then in this case, we should think like I'm failure only, correct?
Yes, app failure only. Because when the app is live, right, there won't be any issues with the app. Like
Uh-huh.
what I say is there
No,
won't be any corrupted
if
app.
it is amp is utilized up to the peak level, right? In that case,
In that case,
it,
this won't be applicable. So if
okay,
app
okay.
is app is 100% utilized, then that is called as hard term thing. So in that case, this channel won't come into picture. This down amp will be
Okay,
coming into picture
okay. This
when
comes
there is an
only
app failure.
picture when there is a failure. Okay, okay. I got it. I got it.
Yeah. So the next one is the disk failure protection. So what will happen when your drive goes down? In that case, Teradata uses the grade one protection, which is called as mirroring, to protect the data against the disk failure. So whenever a disk drive one goes down, then automatically the drive two will be utilized. And Teradata will have the automated ticket and they will modify, means they will change the drive, other drive.
Okay, okay.
Again, this for disk failures. The So whenever we are having the RAID one or the fallback protected, right? So twice the data of the disk will be utilized for this replication. Okay. So the next one is yeah. So
These are all physical disks or virtual disk. There is a two disks are there, right? In Teradata.
yeah, these are physical disks. Like see if uh, each amp will be having one virtual disk kind of thing, but in that virtual disk will be containing several physical drives, physical disks. If you see here, although each amp has exactly one virtual disk assigned to it, several physical disks make up this V disk. Okay, so the amp,
Okay,
right?
okay.
The amp will see that to be one V disk, that is a virtual disk. But in background, that virtual disk will be containing several disks.
Okay, okay.
So that is the difference.
Okay, that means that virtual disk is a logical partition of memory, right? I think.
It's not the logical partition. So how it is considered as a virtual disk, right? Like consider we have 10 disk assigned to one amp. Okay. So what the amp will see is it will consider all these 10 disks to be a single V disk. So it won't think about the different disks. Okay, it will consider a single V disk. So for AMP, it is a V disk, but in physical structure, it consists of several disks.
Okay, okay, okay. Okay, that's why it's called as a virtual disk. Huh?
Virtual disk, yeah.
Okay, okay. That is a
Combination of
combination
physical
of
disks.
okay, okay, okay. What I thought was something like logically or memory. This one RAM level, they are giving some space for the disk, and that disk is connected with this physical disk. I was thinking in that
No,
sense.
no. Only our PE and NAMs will be loaded into the RAM. So the disks will be again into the disk drive only.
Okay, okay. And Binet is also in RAM only, correct? Or what exactly?
Binet is a separate thing. It won't be loaded into
Oh,
the.
Binet. Okay, Binet is a program, no, that will require CPU also.
Right.
Okay.
Yeah, so it's a communication channel.
Okay.
Like you can consider that
Okay.
like
Okay.
fiber
That means
network cable.
PS and AMP. That memory will be taken from RAM only.
Yes. So whenever the system is booted up, these PEs and apps will be loaded into the memory, and from there it starts working.
Okay. Okay. Fine. Okay. Okay. Yeah, I got it. Okay.
So when we don't have this no fallback and we don't set this RAID one, so in that case the data will be lost.
Okay.
And the next one is node failure. So this is achieved by click. So click is nothing but a mechanism used to protect data from node failure. So it's a set of Teradata nodes that share a common set of disk arrays. So when a node fails, then the vprocs from the failed node will migrate to other nodes in the click to continue to access the display. So if you see here in the picture, right? So this is a 4-node click. We have this node 1, node 2, node 3, and node 4, all connected to this disk arrays. Okay, array 1, array 2, array 3, and array 4. So these are different arrays, right? So if we see from node 1, the connection will be there for all the arrays. Okay, and even from node 2, it will be connected to all the arrays. Similarly, for all the nodes, it will be connected. Suppose in the case, the node 1 goes down, right? So what will happen? All the vprocs from this node 1, means the AMPs from this node 1 will be automatically migrated to any of the available node.
Okay.
So from there, it will be again start. So it will again start retrieving the data.
Okay.
So this is for node failures. So how this will be achieved is through a hard standby node. Okay, so a hard standby node is a node that doesn't participate in the production network, but it will be still on and running, but it won't be involving in any of the requests. Okay, it will be just a standby. If a node fails, then the vprocs from the failed nodes will migrate to this hard standby node. Okay. So once the failed node is recovered, it becomes the hard standby node. So usually, if you have a 8 node structure or 10 node structure, mostly 2 nodes will be standby. So whenever a node goes down, this hard standby will come into the picture.
Okay.
So here, in this example, we have a 2-node structure with the click.
Okay, when everything is going normal, that standby nodes are not working,
involved, right? In any, those won't be involved in any of the operation.
Okay.
That will be still standby. There won't be any processing or memory utilization from this hard standby. Everything is normal.
Okay. Yeah.
So I told, like, when you have a 10-node structure, 2 arms will be 2 nodes will be the hard standby, right? So in that case, they will split this 5 nodes to be 1 click and the other 5 nodes to be another click. So one hard standby will be assigned to 1 click and the other standby will be assigned to other nodes, like 5 nodes. So here in this example, we see 2-node structure with 1 hard standby as a click. Okay.
Okay.
So this is something about this standby nodes. So our standby nodes allows spare nodes to be incorporated into production environment. Okay. So Teradata database can use spare nodes to improve the availability and maintain performance level in the event of node failure. So again, this hard standby node is a node that is a member of the click does not normally participate in Teradata database operations can be brought into participate into the operations to compensate for the loss of the node in the click. And this configuration of a hot standby node can eliminate the system-wide performance degradation associated in the result loss of a node. A hot standby node is added to each click in the system. So depending on the clicks, number of click you have in your environment, so each click will have a standby, as I said earlier. So when a node fails, all the amps, the LAN attached PEs on the failed nodes will migrate to hot standby. So
Okay.
this hot standby eliminates the need of restarts that is required to bring back the failed node. Okay, and degraded the service when the vprocs have migrated to other nodes. Basically, it's like a hot swappable node where their users or business won't feel any degradation even a node goes down. So the next thing we'll be seeing about is the permanent journal. So a permanent journal in Teradata provides the capability to capture the snapshot of the tables before and after applying the changes. Using whenever you're using a DML statements like insert, delete, and update. So what this permanent journal will have? It's split into two, as we saw earlier. One is before journal, the next one is after journal. So before journal, we'll have the snapshot of changes before the DML operation, and the after journal will contains the snapshot of changes after you are performing the DML operations. Okay. So unlike this transition journal, which captures a snapshot of table before applying changes and discards upon the commit, it stores in a journal table. Okay, so we saw like transition journal automatically comes in and then it stores the data, right? So in this case, when we specify a table to be a permanent journal, so use this permanent journal. So we need to specify the permanent journal table. So that we'll see in upcoming slide. And this requires Teradata permanent space until we drop it explicitly. Right. So we can control this permanent journal, but transition journal can't be controlled. And this permanent journaling is not supported for primary index tables, column partition tables, global temporary tables, and volatile tables. Okay, so there are 4 types in this permanent journal. The first one is no, means after change images are not maintained for the table, like after or before changes. So do here, that case, 2 after and before changes are maintained for the table. And local means single after image journal for a non-fallback data table are returned on the same virtual lab as the change data was. So local means whatever the snapshot will be taken, all the snapshots will be in the same AMP virtual AMP. Yeah, okay. So wherever the data resides, the same copy will be maintained in the same AMP. So that's what it. And not local is the is the feature where single after image journal of rows are filtered into another app in the cluster.
Okay. How we can configure journals in Teradata?
Yeah, that's what I will say there. So,
okay, fine. Yeah. I just need to understand that one also. Yeah.
yes. I will let you know. So what are some of the advantages of this permanent journal is like permanent journal protects user data against the like loss of data due to a disk failure in the table that is not fallback or write protected. Okay, so in case if we don't have a fallback or write protected, so if we have this journal, then we can still retrieve the data. Right. And loss of data because of 2 or more RAMs fail in the same cluster. So suppose we have this mirroring or fallback protector. So in that case, when we have 2 or more RAMs fail in the same cluster, then in that case, this permanent journal can help. So incorrect batch or application processing. So basically, it will protect from the AMP failures and also disk failures. So you can define the permanent journal in database level or table level. Okay. So a single journal table will be maintained in on database or SSL. So we'll see about this, how to maintain this journal. So once you define a permanent journal for a table or tables and start doing the operation like insert, delete, and update on the table, permanent journal will start to grow, and also it will take the additional space because this permanent journal we are specifying the perm space of the system, right? So we need to make sure this not going beyond the limit. So it's a responsibility of the DBA to maintain the permanent journal by deleting and archiving. Okay, so you can archive and delete the records, the old records. Okay. So during creation of this permanent journal, you can specify to capture the table snapshot as we discussed earlier. So first we'll see about this before journal or before images. So in this case, snapshot will be captured before applying any changes on the table. This is used for rollback or undo the changes. Okay, so you can choose this snapshot of tables as a single copy, a dual copy, or no copy. So again, for after journal, so the snapshot will be captured after applying the changes on the table level. Right. So again, this is you can specify it to be a single or dual copy or no copy. So first you need to create one journal table either on the same database or any other database or user space again. So you'll see about this. So this is the syntax for creating the journal. So if you see here, we are making the permanent journal at the database level. So create database, MyDB. Okay, this is the permanent. We are creating a database basically. From test DB, okay, we are giving the permanent space. We are giving it as no fallback. We are giving it as no before journal. So here, if you see, we are giving it as a after journal. Okay, and default journal we are specifying as MyDB.myjournal. Okay, so we are creating a database called MyDB, and also we are having this journal table inside this MyDB only. Okay, so this is for database level. So when it comes to this table level, right? So here we can see I create as a table MyDB.mytable. We set it to be no fallback, no before journal, and after journal we are enabling where we will give the journal table like MyDB.journals. So this is the journal table. Okay. So this MyDB journals will act as the after journal for this table. So whenever a DML operation is taking place in this, so this will hold the records.
Okay, this journal is common for any other table, right? It's not specific to a table.
If you specify this journal on this table level, right? So it will be specific only to this table. This MyDB.journals, because we are creating a table, we are specifying this journal table, right? So this will be specific to this table. So in case if you are creating another table, you can create another journal table.
Oh, okay. So it's not like one table you will take care of other journal configured tables, right?
Yeah, usually we have it for different journals.
Okay.
So you can even delete these permanent journals as we saw earlier. So if you think like the permanent journal is no longer required, you can drop that after modifying a table or database properties. So you can do that in 3 ways. Like you can either do alter table. Okay, my db.table name is the table we created. So we can give it as no before journal, no after journal. So in that case, whatever journal is there, it will be disabled. Okay, or else you can give it as like modify user my db.table name as no after journal, or you can even do a modify user and then you can drop this default journal where you can specify the journal name. Okay. So this is how we we maintain we modify these tables to remove these permanent journals. So we can find out about these journal tables from all over the system by using this data dictionary dbc.journals. So this will give you all the information about whatever journal tables available in your system. So this is about the data protection.
Okay.
So we saw about just a recap. So we saw about this transient journal where this is useful whenever a transaction is getting paid. We saw about this permanent journal where we can have before or after images of the table, which is getting manipulated, which is getting changed. And we saw about this down app recovery channel whenever the app goes down, and whenever this failure right will help us, and when there is a no failure, our bank will help us on standby.
Okay.
So this is about this of the data protection account. So in case if you have any queries on this. And one thing I forgot to say here is when you specify this this journaling, right? For command one, you can specify like here we have after journal, like we can say like dual after journal will have 2 journals. So similar for the table also. So we saw this right here. So no dual, local, not local. We can change this in the create no or alter. Anywhere we can utilize it.
Okay.
So
And this configuration of which should be the fallback app and these things, who will do that?
This should be set when you are creating a table. So when in your project like new organization, if they consider okay the table is very critical, we can't lose the data at any cost. So in that case, we can have these journals enabled. But mostly, I have not seen even in a single case where these journals are being enabled. But
Okay.
maybe in banking or any other project where they think that the database or table is very critical and they want to have the journals and callbacks and regular.